All right, these are the problems from your flip video last night, yes? You recognize them? Also, please notice that they're on the front of your paper. They're on the front of your worksheet, okay? So we can be filling out that small part of the worksheet as we go, okay? 3/7 plus 2/7. You notice that there is a common denominator already, and in order to add or subtract fractions, we have to have a common denominator, okay? Denominator is already common. We keep that same denominator, but add the numerators. So I just get 5/7, okay? The second problem, 8/11 minus 3/11. I already have a common denominator. That means the denominator is the same, right? It's the same. So I keep that denominator. It's the same as it was a second ago, but this time I subtract the numerators. Yes, it's okay. Ask me.
On the steps, you ask me.
We'll talk about the steps in a little while. Okay? Yeah. Right now we're just writing down the math problems. Okay? So 8 minus 3 is 5. Got it? All right, here's the next one. We notice that they don't both have a common denominator, right? One's 8 and one's 4. So, I mean, you can already see my work, but if you couldn't see my work, would you know the common denominator was 8? No. I have to think, what is the number that both of these will divide into? Okay? So I would have to say, if I was doing my little division problem like this, 4 divides into what? 8 divides into what? But both of these things have to be the same number.
8.
See what I'm saying?
Yes.
So earlier people thought the answer was 2 because they were thinking, what number do these both divide by? Right? And I get that. I understand that. Okay? I have to fix your thinking a little bit though. Right? Otherwise today is going to be a train wreck. Not good. Okay? So here we have 4, here we have 8. What do they both divide into? That's going to be an 8. Okay? They both divide evenly into 8, don't they? All right? So if I make both denominators an 8, well, this didn't change anything, did it? Well, if the denominator doesn't change, then neither does the numerator, does it? Here, the denominator went from a 4 to an 8. All right? I know that you can add 4 to 4 to get 8. But are we adding to get to the new denominator? Ever? Never are we. Okay? We're always doing multiples. We're always talking about factors. Okay? So 4 times 2 will give me 8. If I multiply the denominator by 2, I also have to multiply the numerator by 2. Do you know why? What am I allowed to multiply any number by that it doesn't change the value of that number? 1, right? Very good. Well, if I multiply the bottom by 2 and the top by 2, what is, let's see, what is 2 over 2? 1. Have I changed the value of this fraction? No, I've just redone how it looks, right? It still has the same value. So now that they have a common denominator, what do I do with the numerators? Add. How do you know?
Because there's a plus sign.
Yeah, there's a plus sign. Okay? And then the last problem, I had a 7 and a 5 as the denominator. How did I decide my new denominator was 35? I just multiplied them together, didn't I?
Oh, can you do that?
Yeah, absolutely you can do that.
Like if it doesn't go into anything,
Yeah.
then you just multiply it?
Exactly.
Oh, okay.
Okay? So this one I multiplied by 5 to get to 35, which means I also multiplied the numerator by 5 and got 15. This one I had to multiply by 7 to get to 35, so I also had to multiply the numerator by 7 to get 14. Once I had a common denominator, what do I do with the numerators?
Add them.
Add. In this case, add, right? So does it change when I have letters and stuff? Okay, the only way it changes is that I have letters and stuff, right? The operations, the things that I do, the steps that I take are still the same, aren't they? So look at this first problem right here. What do you notice about these two fractions? They have the same denominator. Whatever the denominator was before, guess what it is now?
The same.
The same. what do I do with the numerators? Add.
2 plus.
That's perfect. And people have said that all day, and I need you to be careful. What is 2 plus x?
2x.
2 plus x,
sorry.
right? How would I get 2x? If it was 2 times x, right? But here it's just 2 plus x. So earlier today, you know what this crazy kid was trying to tell me? If I could cancel the x's. Why is that crazy?
Because you can't.
Because you can't. That's exactly right. Do you know why? You can only cancel, you can only simplify terms in the numerator and the denominator if they are factors. Remember that from yesterday? If they're factors, you can simplify them to 1. If not, you can't. This x is clearly subtracting 4. This x is clearly adding 2.
So if it's
Neither one of them are multiplying to the rest of the stuff. So it's not a factor, so say it.
what I just said?
Yeah.
So if it's the same, like, if it's both, like, if it's both addition.
If it's both addition, you can't cancel it.
You can't.
This is the answer. That's it. Okay? So what about this one?
It's the same.
Same denominator, so it stays the
Same.
same. What do I do with the numerator? Add. This one's slightly different though, isn't it? What am I having to do?
Do you have to do 2x minus 3 first?
You can't.
Like, you can't.
Because they're not like terms.
Oh, the 2x and the 5.
2x and the 5x is what? 7x.
Is it squared?
Oh, that's a good question. Is it squared? Well, we're not multiplying, so we don't mess with the exponents, do we? Okay? 2x plus 5x is 7x. Negative 3 plus 7. Plus 4. Done. Any questions? I'm just trying to give you a chance to think. So how is the next one different?
Well, there's
Or is it?
no, it's not.
Okay, to start off it's not, right? Common denominator, so the denominator stays
That's right.
the same. Then what?
Then you gotta.
Then we add the numerators, right?
2x minus
No? Why don't I add the numerators?
Because.
Yeah, because it says subtract.
Oh,
Right.
that's when you can cross.
2x minus x.
X.
X. 11 minus 9. Plus 2, right?
Plus 2.
Can I cancel out these x's? Good. You can't. Okay? I need to make you aware, though, of a common mistake here. Okay? I'm not telling it to you to put it in your head. I'm telling it to you so you can avoid it. All right? A lot of people right here say the answer is x plus 20. Why did they say x plus 20? Yeah, 11 and 9. 11 and 9 is 20. Why did we write 2? Because it's subtraction. They remember the 2x minus x, but then they just combine the next two terms and get 20. So my caution to you is to just be careful and remember you are subtracting. Okay? Yes, sir?
Why is it plus 2 instead of minus 2?
Because it's 11 minus 9, and 11 minus 9 is 2.
Oh. Right.
Does that make sense? Okay. Are we ready to go on, or do we have any more questions about this one?
Ready?
One person's ready? You good?
Ready.
I'm ready.
Okay. What about this one then?
Is it the same?
It's the same, so it stays the same in the answer, right? Good. Now what?
You take 9x from x,
So x minus 9x equals what?
8x.
negative 8x.
Negative 8x.
And then 3 minus 7 is negative 4.
Ooh.
3 minus negative 7 is 10.
3 minus negative 7, right?
I want to break.
I know that's what you meant. Can I show you something that helps some people? I know it won't help everybody because some people are okay with what we just did. But let me ask you this question. 5 minus 3. 5 plus a negative 3. Are those the same?
No.
Is adding the opposite similar to subtracting? I mean, you get the same answer, right? So what if I added the opposite of what was there? Would that help a little bit? Because then you can see very clearly it's x and negative 9, which is negative 8x, and it's 3 and 7, which is 10.
Yeah, that would help way more.
If it helps, do it. If it doesn't help, don't do it. That's one of those things, right? I'll do it with the problem above it. Okay? I'm subtracting, so I'm changing the sign of everything that I'm subtracting. So I have a 2x and a negative x, which is x. I have an 11 and a negative 9, which is a positive 2. Does that help? If it helps, do it. If not, it's the same thing we just did. It just looks different. Fair enough? Okay, you ready? Here we go. I've got to find a common denominator.
Multiply the denominator by 3, and then you have to multiply the numerator by 3.
Okay, so you're saying that this one has two factors, and one is a 3 and one is an x. And this one only has one factor, and it's an x. So it's missing a factor, right? What factor is it missing?
3.
If I multiply the denominator by 3, I have to the numerator by 3. So here I have 5 and 3x, and here I have 3x plus 3 over 3x. You okay so far? Equals what?
3x plus 8 over 3x.
Somebody please tell me one wrong thing that people try to do right here. Take the 3x's out. Can you do that? Is that 3x term being added or subtracted to anything around it? Then it's not a factor and you can't do it. So guess what that is?
The answer.
The answer. Yay! You guys need to calm down about this. You're getting too excited.
This is easy.
Okay, you ready for the next one then?
She's speaking too soon.
It's fine. It's fine. I know she's speaking for herself. It's okay.
Wait, I spoke too soon?
Yeah.
I'm scared.
If I wanted you to be scared, I would make you scared. Yes, that is a promise. Ready? Before I can do this one, to make it make any sense at all, what do I need to do?
Do the denominator.
I need to do something with the denominator, right? How about if I factor the denominator? What if I do that? Does that help me at all?
Yeah.
Does it help you to see that they both have a factor of x
Yes.
plus 2?
Yes.
Okay, so what is this? How do I say this?
Wait, why'd you do the 2 instead of the 4?
Because the first term is not divisible by 4.
Oh, okay.
Okay. What should I do, you think? They both have a factor of x plus 2, right? But what does this also have?
A 2.
Then what does this one need?
A 2.
A 2. Because they both have to be the same, and we can't take anything away. We've got to multiply by something that's missing.
Yeah.
Okay? So here I have x plus 1 over 2 times x plus 2. And here I have 18 over 2 times x plus 2. Why did I not write 2x plus 4? Why didn't I do that? Because it's dumb? Okay. It's an extra step I don't need to do, right? I already undid it. Why would I redo it? Because maybe what happens next if the next step is to undo it again? That's a waste of time. Okay? So, what's my answer here then?
What's my 2?
X?
Okay, so
1 minus 18.
17. Negative.
Perfect. questions so far?
Nope.
Yeah.
Ask me.
So those parentheses still need to be in the question.
Yeah.
I mean, in the
Oh,
answer?
yes, thank you.
Oh, okay.
Okay.
Sorry.
You're fine.
On the next one,
Ask me.
could we need to add like an X or 3Ds or one? Or did we-
I need you to be careful how you say that.
I mean, it matters which one we add, but like which one will we?
So the problem with my problem with what you're saying is not the numbers you're choosing, it's the verb you're choosing. What verb did you choose? You said we needed to add a 3 or add an X.
Or subtract. Multiply.
It would be multiply. Okay?
Oh.
What is this one missing?
Is it missing a 3?
It's missing a 3. What is this one missing?
An X.
An X.
So do we have to go to the top and add? Not add, but multiply?
Okay, listen guys, she's asking a very good question and you need to know the answer. If we multiplied this denominator by a 3, what do I have to do to the numerator?
This thing.
Multiply by 3. If I multiplied this denominator by x,
3.
I have to multiply this one by x.
Oh.
Okay? Why did she say a 3 and an x?
Oh.
Why did she say that was the correct denominator? Do you know? Or did you just go along with what she was saying?
I just want to learn it.
Because I need you to know.
Well, it looks right.
Well, it is right. That's why it looks right.
Yeah. Sounds good.
You can do it by yourself, you think?
Can you tell us why? Or tell me why?
I needed to find something that they had in common. And right now, they didn't have anything in common. One had an x and one had a 3. So I made the other one have the 3, and I made this one have an x.
So would that be x squared? That 2x squared, would that be squared since you're multiplying?
This one would be 15, right?
Yeah.
Over 3x.
Yeah.
And this one would be 2x squared. Yeah, absolutely.
There you go.
Over 3x. So what's going to be my answer?
15 minus 2x squared.
15 minus 2x squared. Yep, absolutely.
Okay.
You know what this crazy kid earlier tried to do? Simplify the 15 and the 3.
They're crazy because you can't.
They're crazy because you can't, right? Everything in the numerator would have to be divisible by 3 for me to factor out a 3 and then simplify the 3's, right? But they're not, so I can't. Okay? All right, ready for the last one? What do you think we ought to do on the last one?
Well, we need to add, not add.
What you got?
I don't know.
I think we should multiply them each by each other. So like. X
I think
plus
that's a very good idea. I think we should multiply them each by each other. If this is 2x minus 1, and this is x plus 3, aren't they the same denominators now? Two x minus 1, x plus 3.
Took me a long one.
2x minus 1, x plus 3. So what goes here?
4, no, it'll be 8x. Negative 4.
Yeah, 8x minus 4. Because we distributed the 4 to each term in the parentheses, right? So what about the other one?
7x plus 21.
Perfect. Now I just have to do what it says. I have to add. What you got? Is that my answer?
Oh yeah, it is. No, just the bottom part. Your answer would be 15x. Oh.
Plus, is it 15x plus 17?
Yes, it is.
And then it's over the parentheses 2x minus 4 parentheses x plus 2.
Yes, that's exactly right. Okay. Any questions so far? Show me with your hands how you're feeling. Not that finger, Brady. The other one, your thumb. Just teasing. Okay, I saw a lot of thumbs up and I saw a lot of thumbs sideways. That's a good sign. Okay? That's okay. Sideways thumbs are okay. All right? All right, look at number 5. Look at number 5. Sometimes some people struggle with a problem like this because they forget how to factor. They struggled with factoring in the beginning and now they have to do it again. So I'm here to tell you, we already went through the lesson on factoring. I might go a little faster when we're factoring here. If you're still struggling, please, please, please come and see me for tutorials because we need to talk through this. Okay? Because I'm just going to tell you that this is a difference of squares, and that's how you factor the difference of squares. If you remember that, good. If not, come see me for tutorials. We got to talk. Okay? I'm also going to give myself some blanks to fill in, like a pattern. Okay? So, what do you notice?
That one has an x minus 2, but the other one doesn't.
This one has an x minus 2, but the other one doesn't, so the other one needs an x minus 2. Numerator and denominator, right? So what my common denominator is x plus 2, x minus 2. Alright, so this very, very sweet child earlier said to me, but it's different. Because this one says x minus 2, x plus 2, and this one says x plus 2, x minus 2. What did I say?
It don't matter.
Well, that's not exactly what I said, but it's close, right? I said it doesn't matter, not it don't matter. Okay? But it doesn't matter what order we multiply numbers in like this, does it? Okay? Are you okay with that?
Yeah.
Okay. So here I go like this and like this, right? 2x squared minus 4x. What happens to the second numerator? What happened to the second denominator from here to here? How did it change? It didn't. So what happens to the numerator?
It doesn't change.
It doesn't change either.
So it's just x minus 4.
Perfect. Now what all am I doing?
You gotta do 2x squared plus x.
2x squared. I've got a negative 4x and a positive x.
Oh.
So negative 3x. Uh-huh. Minus 11. Yes?
Yes.
Yes.
That's it?
Mm-hmm.
It was easy.
6. You ready? Okay, so first I'm going to factor these two and get x plus 3 and x plus 4, because that multiplies to be 12 and adds to be 7 is 3 and 4. And then I'm just going to factor out a 2 here. That's all I can do. And get 2 times x plus 4. So what do you notice? There's no x plus 3 in the second part, so I need 1. And there's no 2 in the first part, so I need that, don't I?
Yeah.
So what do I end up with?
Well, the denominator is going to be the denominator.
Uh-huh. 2 times x plus 3 times x plus 4 is my denominator.
Would it be 2x?
Yes?
And then
2x plus
Plus 9.
2x plus 12. I multiplied this denominator by 2, so I had to multiply this numerator by 2. When I distribute it, I get 2x plus 12. Yes or no?
Yes.
Okay. This denominator needed an x plus 3, so I multiplied the numerator also by x plus 3, so I get
5x.
plus 15, absolutely. So when I go to combine my like terms, I still have my denominator of 2 times x plus 3 times x plus 4. What do I have in my numerator?
3.
Would it be negative?
Negative 3x, because it's 2x minus 5x. And then, say it.
What do you get?
Negative. Negative 3.
Yeah.
Oh, sorry, Brittany.
Okay. The pretend bell is going to ring any time now, right? It's not ringing today, so I'm going to go ahead and finish this problem. You guys can probably go in about 30 seconds. I'm going to finish this problem so that it's on the video for you.
What's our
Okay?
homework?
So if you want to go see the video tonight, this problem will be on the video. The homework is 1 through 8. Okay? I'm going to do this problem. X plus 2, x plus 4, and this is x plus 2 and x minus 3. This one needs an x minus 3. This one needs an x plus 4. So when I go to fill out my plus, I get x minus 3, x plus 2, and x plus 4. X minus 3, x plus 2, and x plus 4. So when I multiply, this out, I get x squared plus 3x minus 3x minus 9. That is 0. Negative 3x and positive 3x, so that's a 0. Then here I have 9x plus 36. So when I go to combine my like terms right here, I have x squared. I have a minus 9, but I also have a plus 9x. A minus 9 and a positive 36 is a positive 27. Over x minus 3, x plus 2, x plus 4. And that's my final answer. Okay?